All right, welcome into episode 4 of RegenAG Nation's Growing Onion Seed Bulbs Regeneratively. Now, up in the first 3 episodes, we've focused almost exclusively on the process behind starting these onions. We've got some overwintering stuff. We've got some bulbs that have been planted recently as well. Now, we're going to be talking about some of the inputs that go along with it. I think it's really crucial to put into the equation. High production ag always has some level of inputs in there. It's about pushing the right buttons and doing things philosophically that are more compatible with plants and soils. And that's what we intend to share as we go along throughout this season. So I'm out here in this overwintering section of onions. I want you to take a look at these things as they come by. They've actually held up really well throughout that harsh winter that we've had, and we're on into the spring here. So now let's talk a little bit about foundationally what we're trying to do in this section. We've focused on really building the biological system, and I think that's important. In regenerative farming, we're not bypassing or skipping the biology in all this. A lot of the conventional mindset is water-soluble nutrients. If we have problems come up, we'll take care of them. Whereas we're trying to actually go out here and reduce these diseases, reduce these pests from ever happening in the first place. And this becomes incredibly important when you're dealing with seed stock and raising seed because we're talking about changing future generations. Literally, the things that come out of here, the characteristics that we provide in these plants, they will continue on into the next generation. They will eventually become seed in a commercial field. And so if we're able to influence root systems, we're able to influence colonization and associations with biologicals in the soil, then we just create a much more resilient seed that's going to perform better in commercial fields at a later time. Okay, so I want to key in a little bit on rooting and root systems. There are some really clever ways to manipulate root systems and plant architecture. As you can see, we've kind of pulled some of this stuff out. We didn't get everything in here. We're kind of doing it down and dirty. We don't want to do a lot of destructive sampling in this plot. But as you pan in and come closer on these things, these root systems are really robust and they're also really healthy. The way that you can tell is they just got that really good white color to them. They don't look dingy. They don't look like they're being fed on. So from that standpoint, so far so good. Now, some of the ways that we manage this regeneratively is really by feeding those biological populations. If we're able to use an inoculant, we're able to feed that with a food source, then microbes will colonize the root system. Now, they need an environment and a place to live. So the more microbes you put near the root zone, the more you feed them, the more they colonize roots, the more roots will be pushed out by the crop. The plant's smart enough to know that it needs the microbes, and if it's doing that, then it's got to provide a environment for them to be and food source. Now, that food source oftentimes is the photosynthesis. So we can't forget that we're really just out here to drive photosynthesis. At the end of the day, we're driving plant energy that comes from the sun, carbon, and water. So those are the most basic inputs that we can't forget. But many times it's the micronutrients and all the minor elements that are fundamentally driving those processes. Manganese is essential in water hydrolysis, for example. So if you don't have manganese in the system, you will not be able to split that atom of hydrogen and oxygen apart and be used by the crop. So we've already talked a couple of times about the microbiology or the microbiome near the root system. Why this becomes important is because it's everything in terms of functionality and what the plant requires. If the plant requires certain elements that are missing, it'll signal those microbes to make that available to the plant. If we have a situation where we actually have pathogens, that dominance of good biology will oftentimes compete and antagonize those pathogens, those soil pathogens, so they can be present and still never harm the crop. Biology is functionality for the plant. It's the necessary components. And that's why oftentimes in conventional farmings and conventional systems, we see a lot of problems that we have to spend a lot on solution-wise. So, all right, so I want to get into the elements that we put into these mixes and programs just so that you have a greater understanding. Follow me over to the newly planted bulb nursery and let's check this out. Bam, look right here. This one just got rained on a little bit, so it's uncovered. You can see it's actually starting to sprout. These ones next to it have gotten a really good head start on that. It's hard to believe that just 10 days ago, these were cut bulbs, planted by hand, and now they're already shooting out of the ground. Okay, so let's talk about nutrition in all this. Well, early in the establishment of any crop, we don't have a great need or a great usage of nutrition. What we want is a little bit of really efficient materials. So phosphorus, for example, really helps establish good rooting systems. But if we put too much phos in furrow or near where a root system is going to be, plant gets lazy and it won't actually create associations with fungi and things like that that are helpful in bringing phosphorus up. So we want to use really efficient materials in on this. We want to use carbons in with our nutritional mix because carbon is everything in the soil. It's everything that we're missing in most soils. We also want to use stimulants. So early in the season, it's usually soil temperatures that are going to hold us back. Oftentimes we can use a simple enzyme product that's very cheap and effective to really get the biology going and to set the foundation for this root system. So the idea would be is let's put a mix together with a little bit of sound nutrition, a little bit of biology in the mix, a little bit of food source, and then let's get these things rocking. So finally, the last thing that we're kind of starting to work on in this project is thrip management. And I know it sounds early, but as you pan out over this overwinter crop, you can actually find thrip in these already. They will overwinter in the soil. They will come out and start feeding. Let's go ahead and take a look and see if we can find any of those in there. Usually they're going to be hiding right down in the neck. You can see a few juveniles there. You can see an adult there. Okay, so we do have a pest present, but let's not panic on this. Remember, we want to keep our beneficial populations out here working in our favor for as long as absolutely possible. So what are the ways that we can manage this? Well, we actually have some in-furrow type of management that we can do through a drip system. There's certain endophytes that are a great start to an IPM program. What they'll do is they'll grow into the root system and they'll continue to proliferate in the crop as it grows. When the insects feed on them, they'll release certain enzymes or VOCs that will reduce that feeding. Now that's a great tool, very cheap tool in doing all this. The other thing that we got to really focus on is plant health in all this. If we manage this crop early with a few foliars, we really get photosynthesis going, we get sugars high in the plant, and everything is kicking on full cylinder. We just won't see it as a hospital place for thrips. Now, when it comes to managing these thrips and utilizing product chemistries to do it, we always start off with softer chemistry that's effective for the pest or the host. And so you can do some things systemically through the drip, which is an option if you do have drip tape. We have done that in these plots. Additionally, there's some material that you can utilize that will be a little bit more beneficial friendly. And I think that's important. We want to keep pest pressure low through plant health, through soft chemistry. We want to remain in a state of symbiosis with beneficials as long as we possibly can in order to achieve the objective. Now, it's important to mention that thrips are of the utmost importance in managing on all this because it really comes down to how much foliar disease you're going to have is going to be tied into thrips. Additionally, the size of the bulbs and just the overall health and photosynthesis. If those leaf materials get chewed on a lot, they will reduce photosynthesis. They will open the crop up to spores and fungal pathogens, and it really just decreases plant health. So managing this in a proactive way is of the utmost importance. Now, we'll talk about this as we go forward, but one of the keys here is we are going to be using a lot of pollinators in these plots. So pollinators are notorious for being a little bit finicky about how they work onion seeds in general. I don't think they love the smell of onions, as some of us may have a problem as well. But beyond that, if you have a lot of pesticides and chemistry, it's almost like the pollinators sense that they don't want to work the umbels quite as well. You don't get as good a pollination, and you won't get as good of a seed set. So I think the key thing in managing this is, as we go forward, if we can accomplish that goal agronomically through plant health, through biology, through soft chemistry, we're just going to get better pollination, better seed set. Overall, we're going to accomplish that goal of bringing more seed into the shed that can be used in next generation seed. All right, so what to expect going forward? We're going to talk about this and follow this through all season long as we continue to manage and raise this crop. You're going to see some strategies, everything from, if we have to apply an herbicide, what do we do to manage our way around that? If we have to apply a fungicide, what do we do nutritionally to manage the plant health aspect of that? Now, as we go forward, you're going to start to see infrastructure in these plots. We'll have cages up on these different varieties eventually for pollinators, and it's going to be pretty cool to see this whole thing go down. We're going to be talking nutrition, we're going to be talking soil health, so stick with us, and we thank you for joining us.